All right, welcome to Serverless Office Hours. We are live. I'm so excited about this one. I haven't been on Serverless Office Hours for a while, and I'm really lucky to be back on it and get to talk something I'm pretty excited about. I want to first of all introduce my guests. First of all, start with our Trek 10 folks. Ryan, why don't you tell us who you are, what you do?
Perfect. Well, first of all, thank you guys for having us on this. We're super excited to be here. So my name is Ryan Toler. I am a cloud architect at Trek 10. I'm currently working on our federal practice. So we do a lot of government contracts. I'm based out of Cincinnati, Ohio. And yeah, just happy to be here.
All right. And Jake, I'm gonna pass over to you. You're in Michigan right now, is that correct?
No. I'm in Ohio. Hey everyone, Jake DeCrane, also a cloud architect here at Trek 10. I work alongside Ryan in the federal practice here as well. From Columbus, Ohio, and yeah, super excited to be here.
All right, very cool. And Andrea, this isn't your first time with us. Tell us who you are.
Yeah, hi. So nice to meet you all. So my name is Andrea. I'm a partner solution architect here at AWS. I am based out of Barcelona, Spain. So very different place where you're all at. And yeah, I am one of the maintainers of the Powertools for TypeScript. So yeah, happy to be here. I'm looking forward to this session.
All right, and I love your Twitter handle. Were you going for Dream Rosie? Or was it?
Yeah, no, it's just that. So it's a coincidence, actually. I got the handler before I was speaking English. So it's actually my last name and my first name kind of merged. But yeah, it's a nice coincidence.
All right. Yeah, I like that a lot. That's very cool. All right, so real quick, Ryan, tell us, Trek 10, what do y'all do?
Well, Trek 10 is a premier AWS partner. We were born in the cloud. So from the very first day, we have been 100% serverless. So that's what we do. We focus on building serverless applications. We have both commercial and a very new budding federal practice that we're trying to build up.
Excellent.
And yeah, I don't know, Jake, if you want to add anything to that.
Yeah, overall, we're just a bunch of really smart people that like to solve really tough problems and prefer to do so in serverless technology. So it's a fun time.
I love it. Yeah, I love it. So I'll introduce myself real quick here. My name is Eric Johnson. I am a developer advocate for serverless. I have been doing serverless since the day it came out. I remember standing in the room when they announced it. I wasn't in the actual room, but I was watching the screen. I was in a room and thinking, man, why would you do this any other way? So I used to work for a partner, and the partner, we did a lot of infrastructure, but I always ended up telling my customers about serverless and helping them get to serverless. And so that's I love it, and that's my dream. And today we're going to be talking about making serverless even easier, kind of from the developer side of it. Mm-hmm. Andrea, why don't you kind of fill us in on what we're talking about today?
Yeah, sure. So, I mean, we're talking about AWS Lambda Powertools, in this case for TypeScript. So Lambda Powertools, for those of you don't know it, is it's an open source project from AWS that essentially helps you simplify the serverless best practices. It's, as Eric said, it's a developer-focused tool. And it helps you basically get into all the practices from the AWS well-architected framework, and specifically for the serverless lens, and essentially allows you to design and your architectures and your workloads as much as possible in a reliable, secure, and efficient way from the beginning. And specifically, AWS Lambda Powertools for TypeScript has launched a couple of weeks ago. So for those of you who were following us on Twitter, you probably noticed. And we launched with 3 utilities. There are Logger, Metrics, and Tracer. So Logger basically is a utility that allows you to generate structured logs in JSON format. Metrics is another utility that allows you to generate business metrics for your applications. So for example, think of, you want to measure how many people have signed up or how many orders have you received. And then there are traces. So traces is essentially when you want to measure the efficiency and profile your applications, and you want to understand where the time is spent during your calculation. So all those practices are not new to serverless. It's not something that Powertools has invented, but our goal here is to make them more accessible and more simple.
Yeah, so it's interesting. One of the things, if you've heard me say this, something I say a lot is the most brittle part of an application is going to be Eric Johnson's code. My title is developer advocate, but that's because my business card can't hold kind of a hack developer advocate, right? So I'm not the strongest developer in the world. And there's a lot of people who are developing who are not the strongest developers in the world. So I love this idea of giving us a framework where we can quickly grab best practices and throw them into our code. The other thing I always say is if all else fails, then code. And what we, with serverless, we really talk to people about using, the step functions and the different things like that. But eventually, to make your application unique and build that, you've got your unique business, logic, things like that. You're climbing into a Lambda function, and we want to bring this best practices to that, where you can again quickly apply these best practices and get to the point, of your code very quickly. So I love it. Hey, we've got quite a few people signing in and saying, hey, Daniel from Sao Paulo. I'll be seeing Daniel this week at the summit. If you want to, if you're watching, I'd love to see you throw in where you're watching from. We always like to see where you're coming in to and why you're doing that. I have a quick survey I like to do with my guests. Ryan, there's no wrong answer, but there is. Pineapple on pizza, yes or no?
My wife would beg to differ, but no pineapple on pizza.
That's right. I'm not talking to your wife. And my wife also puts pineapple on her pizza. But in spite of that, I love her. Jake?
Yeah, no pineapple on pizza.
Good.
No pineapple on pizza.
Well done. Andrea, it's really down to you.
No, man. Like, as an Italian, no, definitely no. It's forbidden. They will revoke my passport if I do it.
There you go. And that's our show for today, folks. Have a good one. So, no, that made me very happy. We are unanimous. No pineapple on pizza. And with that, I think, Ryan, I'm going to pass it over to you. You're going to share your screen. And so what we're going to look like today is we're going to spend a little time kind of giving the background of why this is, what we're doing here and why this exists. And then we're going to get into, stay tuned with us because we're going to get into some practical. Jace can do hands-on keyboard and live code. He's daring. He's crazy. We're going to get at it. So, Ryan, are you ready for me to share?
I am ready.
All righty. The floor is yours, sir.
Perfect. All right. Well, the agenda today kind of looks like this. So first, we're going to talk a little bit about, why you would want to use, Lambda Powertools. We've already kind of hit on that a little bit, but I want to dive in a little bit deeper just to show more of the benefits of it as a whole. Then we're going to focus mainly on AWS Lambda Powertools for TypeScript, looking at the three core utilities, logger, tracer, and metrics, and we'll get into some code snippets there. And then finally, we're going to finish up with a practical example of actually using Powertools in a real world situation. And Jake's going to do a little bit of a hands-on keyboard. We're going to show you the full, no pun intended, power of Powertools in the console. So with that being said, let's go ahead and get started. So why would we want to use AWS Lambda Powertools? So I'm going to get a little bit of a backstory. So obviously Lambda is great to use. It's incredibly easy to run code without thinking about servers. Allows developers to focus on what they do best, code. But as you know, code can kind of be a liability. And so with serverless architectures, there are obviously new challenges and complexities introduced. And a lot of times, these aren't trivial challenges to solve, and you actually have to solve them with code. And that kind of takes away from focusing on your core business logic. You have problems such as, debugging, tracing, figuring out how to actually operationalize your workload. Idempotency is a very big challenge that not a lot of people understand within serverless architectures. So, trying to figure out how to do all of that along with writing your business logic can get a little bit complicated. So the AWS well-architected serverless lens, it defines all these best practices on how to actually design and build your serverless applications to solve some of these challenges. But again, it's still difficult to really understand how to adopt these. How can you make this? How can you put this into your application without really muddying up your business logic? This is where AWS Lambda Powertools comes into play. And this is why it's so powerful, because it provides a suite of utilities that makes it easy to adopt all of these best practices that were outlined within the serverless lens, such as centralized and structured logging, tracing, custom metrics. There's so much more. And so really the benefits of using this is to reduce all of that boilerplate code necessary to solve all of these challenges. It'll let you keep your Lambda functions lean, so you can really focus on these on your core business logic. And it'll allow you to just adopt all of these best practices without really even thinking about them. The best part is that this works with both Python, Java, and Node.js Lambda runtimes. And actually, .NET is in preview now. I think I saw as of a couple of days ago. So it's PowerTools is really growing to kind of hit all of the Lambda runtimes. And really, the best part is the AWS community support. The community is fantastic. I know a lot of the features that come out of PowerTools really were driven by the community, and AWS really does listens to everyone using it and builds features that everybody will love. And obviously, it's AWS open source, so that you can trust using the library and put this into your Lambda functions and know that it's just going to work really well. So let's dive into PowerTools for TypeScript specifically. So AWS Lambda PowerTools for TypeScript ships with 3 core utilities for right now. It was just released into GA a few weeks ago. I actually wrote a blog post on that not too long ago. But the 3 core utilities are Logger, Tracer, and metrics. And these core utilities really focus on the operational excellence pillar within the serverless lens. And they try to help solve centralized and structured logging, as I mentioned, distributed tracing, and metrics. The logger really is just a very opinionated logger that outputs structured JSON so that you don't have to. This is really nice when you want to actually create queries and log insights, and you can actually create advanced queries and find different things that you might not normally find if it's just pure string output. Other features that it provides is being able to automatically capture the Lambda context and cold starts in all of your logs. This is very crucial when you want to understand what the context of your Lambda was at that point in time. Another really cool feature is a bring your own formatter. So, if you don't like the default format, you can always change it up to really align to your specific organization standards. The tracer, again, is just a wrapper around the AWS X-Ray SDK. What's cool about this utility is that it could automatically trace all the HTTPS clients. So if you're making HTTP calls in your Lambda, it'll automatically trace that and send that to X-Ray. It also supports tracing the AWS SDK clients in both versions V2 and V3. And it can also capture other annotations for X-Ray traces, like cold starts and the service name that you're working in. And lastly, metrics is a utility to help create custom CloudWatch metrics using the embedded metric format. So you don't actually have to worry about understanding how to create a metric using this format. It'll do it for you. And the best part is there's no added latency, as this does this all asynchronously in the background and sends all this to CloudWatch. So really, all of these utilities allow you to focus on building out your Lambda function and focusing on your core features without worrying about how to solve all of these other challenges that we had mentioned. There are a few ways to actually instrument PowerTools into your Lambda function. And if I haven't mentioned already, AWS Lambda Powertools for TypeScript is also compatible for JavaScript Lambda functions. So if you have existing JavaScript Lambda functions, you don't have to, refactor to TypeScript or worry about any of that. You can actually use Powertools and those just like you would with TypeScript. So no worries there. It's the implementation is almost the same. But there are 3 ways to implement PowerTool or instrument PowerTools. The first way is using MIDI, which is a Node.js middleware engine. This is the easiest way to get started with the fewest lines of code. It has probably the most seamless integration. And it also supports JavaScript. The only con I would say is that it is an additional dependency. So if you're really worried about your dependencies, maybe go a different route there. The other way is a method decorator, and this is really primarily meant for Lambdas written with TypeScript classes. So if your Lambda functions aren't already written as TypeScript classes, this will require the most significant amount of refactoring. So just keep that in mind. And lastly is manually. So this will offer the most granular control. There's no added dependencies or refactoring, but this is also the most verbose approach. And this can actually add a little bit more boilerplate code. So the real power of PowerTools is removing all of that code. We're going to actually show how to instrument PowerTools using MIDI. That's my preferred choice of when using PowerTools. So we're going to talk about the logger utility first. Right here, we have a code snippet on implementing the PowerTools logger. As you can see, there's not a lot of code here. Very, very few lines of code. The pattern will be the same for every single utility in PowerTools, where first you'll start by importing the modules. We're actually going to be importing some middleware as well, because this adds a little bit extra functionality to the logger. We're also going to be importing MIDI, which is that middleware library that I was talking about. All this is on their documentation. So, if you get stuck, you can always go back there. But really, all it is just instantiating your logger and using your logger like you would console.log. It supports all the same log levels, so you can do debug, error, warn, whatever you want. And the benefit here is that you'll be able to have all of your JSON outputted, or all of your logs outputted as structured JSON instead of a pure string. At the very bottom, this is where MIDI comes into play. And so this is how you use MIDI middleware. And we're using the inject Lambda context middleware here, where we are going to be automatically injecting the Lambda context into every single log. So you don't have to do that yourself. Another optional feature, which is disabled by default to really prevent sensitive data from being logged, is to automatically log all of Lambda invocation events. So you don't actually have to have another log statement if you want to log your Lambda event. So that's as simple as either creating a environment variable, which we'll get into a little bit later, or you can add it here within the middleware itself. So this is just the JavaScript implementation of the previous code. It's slightly different, but as you can see, it's pretty much the same. There's about the same amount of lines of code. And again, I'm going to do another shameless plug. If you want to get or understand how to use this with JavaScript, I wrote a blog post on it. It's on Trek 10's website, and it'll go more into detail on how to implement every single utility with using JavaScript. For the sake of this demonstration, we're going to focus mainly on TypeScript. The next utility is Tracer, and as you can see, the pattern is very much the same. We're going to import all of our modules here. The only thing different about Tracer is that if you want to capture traces from AWS clients, you actually have to patch those clients. So In this example, we're going to be patching the DynamoDB client. This is a V3 client, so we're using the capture AWS V3 client method. And within the handler itself, we can optionally add additional custom annotations or metadata, and this can be used for further filtering out your traces or adding extra metadata to them. The middleware that we're using here is the Capture Lambda Handler middleware. And this is great because it will automatically handle the lifecycle of all of your segments, and it'll automatically capture all of your HTTPS clients. So you don't actually have to separately patch those clients. The last thing it does is that it will also automatically create cold start and service name annotations on all of your traces, which can further help you filter out your traces. One thing to note here is that make sure that Lambda active tracing is turned on. A lot of people tend to forget this sometimes, and they may go ahead and implement the tracer and see that it's not actually working. You'll have to make sure that active tracing is turned on when using this. The last metric that we're going to talk about today before we get into the demo to show kind of how this is used in action is the metrics utility. And this utility just makes it extremely easy to create custom CloudWatch metrics. The pattern is very much the same. I won't get too much in the imports. The only thing to note is that you can add a custom namespace for all your metrics. So that in CloudWatch, you'll have a namespace for your metrics. And then within the Lambda handler itself, if you want to create a custom metric, it's as simple as adding a metric. And then with the middleware that you can use with MIDI, log metrics, this will automatically validate, serialize, and flush all of your custom metrics in the background asynchronously, so you don't actually have to do anything there. Whenever you run your function, your metrics will get uploaded to CloudWatch. There's no additional overhead. This is all done asynchronously. So as you can see, there's very little boilerplate code, and MIDI allows you to pretty much do a lot of this stuff in like a single line. So, outputting or instrumenting any of your existing Lambda functions is super, super simple. And with that said, we kind of went over all the specific utilities. I'm going to actually hand this over to Jake, and he's going to show you how to use a lot of this stuff in action and show you the pure power of AWS Lambda Powertools for TypeScript in the console.
All right. Before we do that, and Jake, I know you're getting ready there. A couple questions came in. First, a couple are related to this, and Andrea was killing it by answering questions in there, but I wonder if you want to expand on it a little bit. Any one of y'all, they were asking, will this affect the cold start, and what's your take on that?
Sorry, you set them up. I missed the first part of that question.
Will this? Yeah, Andrea, you were muted. Will this affect the cold start? I think Andrea, you were going to say something. We seem to have lost. We can't hear you, Andrea. Brian, do you want to jump on that? And Andrea, maybe rejoin, see what's going on there. Do you have any comments on that, or Jake?
So it should really have very limited overhead on cold starts. I know with all Lambda functions, you're going to get cold starts, but by importing and instantiating, the log, all the utilities within the global scope, these all get cached. So, I mean, you'll have maybe a little bit of overhead, and we can actually show you the overhead within X-Ray as we get into our demo. But every subsequent call will be cached, and so there will be no cold start.
Additionally, it's one of the tenets to make everything as lean as possible, and to really make sure that you're not affecting the performance of the Lambda function as much as possible. So there's a ton of like benchmark blogs out there you can look at to see the impact of performance based off of the different features.
Okay. The other question, this is easier to ask, is Ryan, can we get access to that deck you just did? I think some folks want access to those snippets. Can you share that out?
Yeah, we can find a way to share that out, and we can maybe put that on Serverless Land or however.
Yeah. Yeah, if you'll send it to me, we'll get it where folks can get at it. There was another question: is how is Java, or how is Java different from how is Power Tools in TypeScript different from Java? Are there some differences there?
Yeah, so as you might know, Java's been Power Tools for Java has been around for a bit longer than us. I believe it's almost a year and some. So we try, when we launch a new Power Tools for a new runtime, we try to release with the same core utilities. So the 3 utilities that Ryan just talked about are going to be in all the different runtimes. But as Jake was mentioning earlier, we have some tenets that basically tell us that we try to be also idiomatic to the language. So there are some utilities that might make sense more in a language rather than another. In the context of Java right now, I know that they have some utilities more than us, like idempotency. So the idea is that each one of the Power Tools utilities tries to be as close as possible to the way the developers would use those tools in their language. So, the same question could be, how is TypeScript different than Java? That is the difference between those utilities.
Yeah. All right, so I'm going to answer this one real quick. It's not necessarily really directed to what we're talking about, but it is service office hours, and we ask for all service questions. And this is a good one. It says, is serverless cheaper than running a cron job on AWS Spot instances? And it's not knowing all the variables. I hesitate to go yes, but most likely yes. And the reason for that is, even when you're running Spot instances, you're paying for instances to sit out there and sometimes do nothing. It depends on how, the variables are, how active is this cron tab, how much memory, those kinds of things. But if you have a cron that runs, periodically, it always makes more sense to just do it in a Lambda function where it's invoked only when it's needed, rather than having an instance, even at Spot instance prices, sitting out there waiting to do this. So you pay for unused resources, basically. So hopefully that helps answer that. Now, Jake, I'm going to turn it back over to you, and I'm going to bring your screen on if you're ready.
All right.
There we go.
Okay. So now that we understand Power Tools, the different features, the benefits, and how to use it, we want to kind of go into a practical example. So in this case, it's a single bus pattern. If you've listened to any of Luke Van Donkersgoed blogs or presentations, he has a lot of great event-driven architectures, and this is he gave us a talk about this kind of architecture pattern about a year ago. So I highly suggest checking it out. But at least for Trek 10 and our clients, we have, especially on the federal side, which both Ryan and I work on, we have a lot of clients that are super, they want to use the managed services. They want to use an event-driven architecture. However, it's really important with security and compliance that everything that enters onto that bus is understood from a shape level of what the information is, what it contains for security purposes, who can produce it, and stuff like that. So in this architecture here, from the left-hand side, you have an API gateway, and essentially you'll have an endpoint per event that would be produced onto this event bus. And that allows us some assurances as far as we can have an authorizer on that endpoint. So we ensure we know who's producing that event, as well as we can have a model that protects the shape and what data gets back into this proxy Lambda function. So assuming that we have an endpoint there and a request comes in, then it goes to this central Lambda function. This Lambda function is responsible for crafting the events that will get emitted onto the event bus. It adds some data enrichment using some kind of best practices for event structures. So Eric, one of your colleagues, David, has a lot of great experience in blog posts and such, talking about like best practices with how you structure your events. So it'll do that, and then it'll submit it onto the event bridge. Event bridge then will get a series of events, which you can kind of depict through those rectangles to the right of the event bridge icon. Those events then would have a consumer or a rule that would pick up on certain attributes. So say we have a video rented event that comes through the bus, and there's a particular consumer that's interested in that event. It would then trigger that rule. In this case, that rule has two targets. One going to CloudWatch, which is writing metadata about what just happened. And this, we'll see in a second, gives us a lot of insights into the system. And then additionally, it writes to a CloudWatch or another event bridge. So in this case, we can assume that that's going to an event bridge in another account. One thing I wanted to mention is that it's generally best practice to only have one target per consumer. But in this case, for observability's sake, we're writing to two, so we have better insight into the system. And so this architecture is great. It has a lot of benefits, but one thing that is tricky with this setup is how do we gain insights into how the system's running? How do we answer questions like who's producing messages? With that message, what downstream consumers are reading off of that or are triggered off of that? Generally speaking, with event-driven architecture, one of the benefits is that I can produce events and I don't care about who's produced or who's consuming it. But from an observability sake, it makes a lot of sense to understand how your system is running and if there's permission issues with triggering the downstream event or all that kind of stuff. But then also getting metrics and tracing to kind of follow the understanding or the logic going through this kind of decoupled system. So the solution here, you probably can guess it, is Powertools. How can we leverage Powertools in this central Lambda function to give us those features of structured logging, traces, metrics, wrap that all in log insights, and really get a good understanding with not adding much boilerplate to this Lambda function, what's happening in the system. So before I go into the console, I first want to lay some groundwork of how this is set up. From an infrastructure as code perspective, we're using CDK to provision our infrastructure. And there's two main things to be concerned about here is on the REST API. This is the level 2 construct. We are enabling tracing. And so that's going to allow us to follow the trace from API gateway into the Lambda function. And then on the flip side, on the Lambda side, we are using the Node.js function construct. And we are also turning tracing on there to, again, ensure that X-ray is going to pick up properly. The other thing I want to point out is that the environment variables in Ryan's demos or code snippets before, he was setting some settings directly on the constructor pre-handler that was setting some information about the logger and all the different service names to track. You can actually set those as environment variables, and we can actually send you a link to the documentation of which environment variables are available for Powertools. But this is a good way for more production level code to, instead of hard coding, rather inject that into your Lambda functions. So here we have one for service name, which gets tagged in like your log, the standard logging in JSON. We have metric namespaces. In this case, they're both named office hours. However, that's probably not the case necessarily in a production workload. Additionally, kind of a cool feature, you can check out the other ones in the link, but another cool feature is how you can turn on and off logging the incoming event off of an environment variable. This is helpful when you're debugging kind of what is triggering my Lambda function. Am I not, what is the data structure that I'm expecting? Obviously, you wouldn't want to do that in a production workload, but definitely a good tool to have. Moving to the central Lambda function. This is the import section of that Lambda function. Just want to quickly call out what you need to set up pre-handler. In this case, we're pulling in the logger, tracer, and metrics from Powertools. We're pulling in the event bridge client using the AWS SDK version 3. And then we're pulling in MIDI as well. So this is using the MIDI constructor implementation style. Outside of the handler, we're instantiating the logger, tracer, and metrics. You can see here on line 9, 10, and 11. It's important that you do this outside the handler so that you take advantages of doing this in the cold start and not having that performance hit on every invocation. Again, another thing I want to note is that these constructors are empty. So we don't have any service names or anything that are put in there. Those are all being injected via environment variables. Lastly, event bridge, we're patching the client here with tracer. And so any subsequent calls with this client will create a subsegment in X-ray, which is a really cool feature. And I'll show you that in the console here in a second. Moving to the meat of the handler, we've omitted some code as far as the logic of how to create that event envelope, which I mentioned earlier. If there's questions on that, I'd be happy to answer. But for brevity, we comment that piece out. Once that's all situated and the data is enriched and we want to send the event, we simply just call a send command on the event bridge client. That will then send the message away. We then create some metrics. So we're adding a dimension of event type and event version. So as different events come in, we can then create a metric of successful event and then track that via metrics. For tracer, we're adding different annotations to the traces, to X-ray, to the subsegment. I'll show you that in the console, but this enables you some really good features or really nice features to search your traces by a AWS request ID, which gives you a lot of cool insights. And you can kind of stitch together your logs, your traces, and everything via this request ID. It's a nice correlation ID, essentially. Put metadata is actually pretty cool too. When you're looking at from a trace perspective, you can add like blocks of JSON for added context, if it makes sense. So when you're looking at a trace and you're trying to debug a problem, you have that added context to add in there as well. Oops. Lastly, we're logging a success metric using the logger. The thing to note here is that we're adding additional metadata to the JSON, the top level attributes of that JSON, of source, detail type, and that AWS request ID, which is pulled from the context variable that you get in your Lambda function. Lastly, before I get into the code, which I know everyone's waiting for, or into the console, this is the kind of wrapping everything together. This is the Lambda handler. We're using MIDI, and as Ryan mentioned, these capture Lambda handler context and metrics. They do a lot of repetitive kind of steps for you automatically out of the box. You don't have to think about it. For logs, you don't have to flush your metrics. For the logger, you don't have to think about adding the context. It does that all for you. So this is, again, a really clean and cool way of instrumenting the Lambda function. So with that, let's get to the code. I'm going to hop over to the console. This is the central Lambda function in that architecture diagram, and it's deployed. You can see that it's being called by API gateway, and then it's hitting that Lambda function, hitting the Lambda function. If we go to the monitor tab, we can see that the different traces and logs that are coming through here. I want to first hop over to the logs to show you the structured logging. I have this in this tab. See here, we have some logs.
Hey, Jake, I'm going to interrupt you. I told you I would. Would you mind blowing that up just a bit and maybe get some feedback from the gang? But this is it's pretty small, so hopefully y'all can see that. Thank you. That's much better. Yep. Is it
better? Awesome.
Yeah. Thank you.
All right, so if I hop in here, this is an invocation of this Lambda function. You can see I had the environment variable turned on to log the event. And so you get this really nice JSON structured format. It tells me that it's a cold start, which is a cool context of when this was run. Some other Lambda information, the log level, and then the event, which is pretty cool. So this is me hitting the API gateway, and this is the payload that this Lambda function is getting, which is pretty neat. If I go all the way down, you'll see the body, which is the actual payload in the post request that I gave. In this case, we are adding the Happy Gilmore title or video to this endpoint. In this case, this is a video rented event that went by. If I go to the next message, you can see a success message. However, the important part is that the source, the detail type, and the request ID were all added to this structure. This adds us a lot of cool functionality when we want to try to use log insights to kind of inspect how our Lambda function is operating, which I'll show you here in a second. But then, well, yeah, so that's basically the structured logging. If I hop over to the next tab, we're now in log insights. So now that I have those logs, how can I inspect what's going on? In this case, we are creating a simple query that is looking at the source and detail type of the logs, and it's looking for messages that are successfully created event. And so that's a log I just shared with you. But it's collecting them. It's creating a stat out of that with a count, and then it's aggregating it by source and detail type. So if I run this query, we will see that in the last hour, 6 video rented events crossed the bus. And to give you a little bit more context here, source, what source means is you can think of this as like service. So this example, we have a rentals service that has a event type of video rented version 1. So if I expand this to 3 hours, I believe there should be some more events out there. There you go. So in this case, the source, there's 2 rental sources. So this service is creating 2 different types of events that are going across the bus. And then we can aggregate the number of times that has entered into the bus. And then we have a different service called accounts that's doing the same. So you can kind of get some cool metrics. This is more of a trivial example, as you could gather this via metrics, which I'll show you next. But you can do a lot of cool advanced log insight queries here to really connect producer events to downstream consumers as well, which is a really cool insight. I'm going to head over now to traces. And so this is tracking the different traces, or kind of the stream of traffic going through the architecture. And so you can see here, if I click on a trace ID, it'll show you a trace map. In this case, basically, this is another rendition of the architecture that I had depicted earlier. You see the client is hitting the API gateway, and then that's hitting Lambda functions, and then hitting the event. If I scroll down, you can see all of the different segments and subsegments that were automatically created. And keep in mind, I added 2 lines of code to my Lambda function, and I got all of this, or really 3 lines of code in my Lambda function. And I got all of this for free, basically, which is really neat. You can see that this segment, index.handler, is coming into my Lambda function, the handler. And you can see a subsegment here of events. So this is the SDK call out of my Lambda function into events. If I check out the annotations, if I scroll down a little bit more and check out annotations, you can see that that custom annotation that I added in the Lambda function had copied the request ID into this trace. And so there's a scenario where, say, a Lambda function fails and you found the log. You can rip that annotation, or the request ID out of that log. You can go to traces, and you can do a query and say, I want to find the trace ID, or find traces by the request ID. So I plop that in and I put in my trace ID. It'll take you directly to that trace, which is a super powerful debugging tool. Lastly, I want to hop to metrics. In metrics, you'll remember that I had created a dimension or 2 dimensions rather, that were emitted every time a successful message went across the bus. So those go under a custom namespace. And as the environment variable I set that to office hours. And you'll see that there's 1 metric in here that has 2 dimensions of event type and event version. And this gives you a mechanism that you can see different kind of facts that happened. In this case, we have a metric name of successful event. Practically, in real life, you'd probably be more curious about failed events, and then you could have metrics based off those, and then you could have alerts that automatically tell you that something went wrong. But for sake of demo, I made a successful event. If I made this like a number graph and made this over like the last hour, or 3 hours, and then made this a sum, you could see over the last 3 hours, we had 7 successful events in this case for the new user event. So pretty cool stuff there. The power really comes in when you start to automate reactions to this. So when you create an event, something happens that triggers an alarm, and then you can take remediation action if required. So all in all, no pun intended, as Ryan mentioned, this is really the power of Powertools. We added, like maybe 10 lines of code to our Lambda function, and we got all of this functionality. We were able to align to kind of that operational excellence pillar of the well-architected framework, and with very little boilerplate, which is really pretty awesome. That's basically all I wanted to cover. Is there any questions?
Yeah, first of all, great demonstration. We have people are digging into this, so really good job. We've got a question here from Alper Codes. Says, are there any use cases where Powertools would be overkill? What are some of the features, data that Powertools can provide that are not available from CloudWatch X-Ray out of the box?
Yeah, so I can take this one. Maybe so the first thing that you need to keep in mind, I think, here is that with Powertools, we're trying to design it in a way that it's progressive. Like you don't have to go and take all the utilities and your Lambda functions and implement them. You can start by adding some of the functionalities. Maybe let's say you want to start adding some logs or some traces, and you can build on top of that as long as they add value to your use cases. Back to your question about what Powertools does over the services. So all the services that you mentioned, like X-Ray, CloudWatch, those are destinations where AWS Lambda sends the data. So in case of traces, it's going to be sent to X-Ray. In case of logs and metrics, it's going to be sent to CloudWatch. So what Powertool does is not to necessarily augment those services, is more to complement, in the sense that with Powertools, we help you as a developer to adopt those practices in a easier and faster way. Just like Jake showed, if you want to build all these logs and these traces, either you have two options really. Either you implement it on your own and you're going to have to implement all this code and maintain it, or you can use a library. And Powertools is one of those. It's a library that comes from AWS, and this is, like Ryan was saying, it comes with some assurances that we are building it with the best interest of the customers and to work well and efficiently on the AWS Lambda platform.
I want to add something on that, and I put in there a quick poll. How many of you are using logging, traces, and metrics now? And I guess in this way. And so I would echo what Andrea is saying is, there's, for any time we're doing logging, there's a lot of setup. There's a lot of, I need this and that, and wiring and stuff that as developers, we a lot of times don't have patience for. And so, well, maybe this developer doesn't, maybe that's why you're better developers than this developer is. But, and so what we're doing is giving you the shortcut to that kind of power. Real quick, it's already wired. It's literally just bolt-on kind of stuff. And so, I love what you said, but I know that I never use it to that degree because I don't take the time to get it running. And so I love it that we've made it that easy. Another question come in here. Can I integrate Powertools into my Kubernetes EKS applications?
Yeah, well, at the moment, not really. So we, as the name also the library suggests, we're focused on Lambda. We want to make sure that these libraries are optimized and good for running in the execution environment of Lambda. But in the future, if there is demand, who knows?
All right. Another question we have, does Powertools provide helpers to push large payloads greater than 256 KB over SQS and S3?
So this is like a really interesting question. So just to give a bit of context, SQS, which is our queuing system service, has some limits on the payloads that you can push to those in those messages in the queues. So the question I think here is that if we have some utilities that help you to push those payloads that are bigger to S3, which is a recommended and common path there. So at the moment, no. But I really like the suggestion, so I would really encourage you to head over the repository and open a feature request. I think it's interesting, and if there is demand, we're definitely going to look into it.
All right. Any future plans to integrate with Smithy?
So Smithy, at the moment, not really. So for context, again, Smithy is Eric. Also here, you can help me out if you know. But basically, it's a meta language that we use internally to generate our SDK, if I'm not mistaken. So
it is. Yeah, we use it. It's an internal tool that we use. It's open source, and I'll actually share the link real quick here. But this is a language for defining services in SDK.
Yeah.
And I'm going to share the link here.
I want to give a bit more context on this of the why we're not looking at it right now. One of our tenets is, as I mentioned earlier, is to be as idiomatic as possible. We want to build for each runtime, we want to be as close as possible to the language and not try to go to the minimum common denominator. So that is why at the moment we're focusing on using the same SDKs that our customers are using in their own Lambdas, so that they can take advantage also of optimizations in the dependency trees and so on.
All right. Well, man, we just threw a ton of information out there. This is fantastic. We've had multiple requests. Will this be live afterwards? If you didn't catch it in the chat, this actually, when we stream to LinkedIn, YouTube, and Twitch at the same time. And so it will literally be, and I posted the link to the YouTube, it will literally be live on YouTube the minute we stop recording. It's live now. So this is posted by Kaiochu. I'm probably just slaughtering that name. I apologize right up front. The Smithy SSDK team might be interested in adding power tools. Yeah, might be something to look into and see that, help it grow. All right. Okay, any other questions you have? Like Jake said earlier, you have some really smart people in the room. You have 3 really smart people and another guy here. So feel free to ask questions. We got just a few more minutes. And we're glad to help out. And if you have serverless questions that are not related, we'll also be glad to jump in. There we go. Any plans on integrating power tools to the serverless workshops?
That's a cool one. So we're working on something. So that's what I'm going to say at this stage. This is we know that right now, especially with Power Tools for TypeScript, we just launched, so it's important that we create awareness and we help developers to adopt it. So yes, this is something that we're looking into it. We don't have yet something that we can share, but stay tuned. And something that I also want to add, since I'm talking about this, is that for those who like to develop Lambdas in .NET, yesterday, we just announced a new runtime for Power Tools, which is AWS Lambda for Power Tools for .NET, which is in developer preview. So if you're into that runtime, please do check it out and let us know what you think.
Nothing as cool as that. I was just going to say nothing as cool as that announcement, but Ryan and I are pretty excited that Lambda X-Ray integration was just released to GovCloud too, which is super applicable for what we do, which is was pretty awesome.
Yeah, we primarily work in GovCloud, and up until like last Friday, X-ray tracing wasn't available in Lambda, and it probably took 5 minutes to add the tracer utility to all of our functions, and now we have full on X-ray tracing in GovCloud, which is fantastic. All of our clients really appreciate that.
But it's kind of an shows how easy it is to implement into your Lambda functions with such little overhead.
All right, we have a couple things coming in. First of all, Honeyfire, I did post that, and man, we love working with our partners. We love seeing our partners hire, and we know that, man, we're all desperately looking for gifted developers. So anytime you see this, take advantage of it. A couple of questions coming in. Donak, by the way, hello, how are you? You're new. Welcome to the stream. Love having you here. We do it every Tuesday, same time, same place. So glad to have you here. Here's a question for you. Would this work on something like OpenFOSS or Knative, or is there some special sauce in the layer that prevent it from functioning?
So I have to be really, really honest. I'm not super familiar with OpenFOSS. But what I want to say here is that the utilities, and here I'm going to talk about metrics and logger first and then for tracer. So when it comes to logger and metrics, we just emit to standard output. So if you have something that can collect those logs that are emitted to standard output and then send them somewhere else, be this CloudWatch or anywhere else, nothing will stop you from using Powertools. So you should be fine, generally speaking. When it comes to tracer, as Ryan mentioned earlier in the presentation, we wrap around the X-Ray SDK. So the X-Ray SDK for Node.js, it's built to talk with the X-Ray daemon. I'm going to go a bit detailed technical here, but essentially it establishes a UDP connection with the daemon, and then this sends the traces to X-Ray. So if you have a listener for those tracer that talks with the same protocol and standard, potentially you could be able to get those segments and traces elsewhere.
All right. We have a ton of questions coming in. We're running out of time, so we're going to do some rapid fire ones. Real quick here. Is there an integration for AWS step functions or a plan for it? Would it even be useful in step functions?
So in terms of being useful, perhaps yes. If you are using your step functions as a part, your Lambda function as a part of a step function workflow, maybe you want to gather contextual information like Jake was sharing about the context, etc. So yes, at the moment, no plans, but please open a feature request on the repo if you would like to see it.
All right. That tech guy has two questions. Number one, is it possible to turn off tracing or logging while a Lambda is running? About step functions, anything specific here, which I think we talked to the step functions one. Yeah. And for I'll quickly answer number one. It would be, you'd have to change it in a redeployment. You'd have to update the deployment. So it's a setting that's part of the deployment. So you could, I guess, turn it off you could use an extension, or you could use something like that you could do a setting. If you're not familiar with settings, you can turn that off and on, and it would be in the code. So
yeah. I will add one thing to that. So for the logger, you can do log sampling. So if, in your production environment, you can only log maybe a subset, like 5% of all of your Lambda invocations if you didn't want to have a bunch of logs in production. And then with the tracer, as long as you use the middleware, it'll actually automatically disable the tracer in non-Lambda environments. So this is pretty useful if you're doing local testing. And you have the tracer utility hooked up. It won't actually run anything X-ray related, so you won't get any errors running those tests locally.
All right. So Alpercode says, I assume to accept PRs to make them work with anything else. So y'all are accepting PRs, yes? I
wanna spend like 20 seconds on this. Yes, we do accept contributions. We follow a process that essentially I recommend you to go on the repo, familiarize yourself with the contribution guidelines, and then everything starts with an issue, with a feature request, and then we discuss it, and then maybe we go to the PRs.
All right. Well, I will tell you, I love this. I know absolutely nothing about AWS, but you have explained things in a way that I can actually get it in my head and understand. Well done, gentlemen. Really well done. On that note, we're going to have to wrap it up. Man, I appreciate Ryan, Jake, Andrea. Thank you so much for joining us in Serverless Office Hours. This is super helpful in helping customers learn and people kind of climb in. All of us have posted our Twitter account here, so if you want to take a quick screenshot, we'll leave this up for a second. Reach out to us. I don't know. I'm just volunteering, Ryan. They'll answer any questions you have on their Twitter. There you go. So, yeah, we all love to help. That's why we're in this. That's why we're in. We do what we do. Is what I tell people. Learn this. So, with that, we will sign off. Thank you again. And everybody have a great weekend. Next Tuesday, we'll see you same time, same place. See you later.